Hi students, in this class I am going to teach you about pi-molecular orbital theory. In this pi-molecular orbital theory, I am going to explain you pi-molecular orbitals, what is the symmetry of pi-molecular orbitals, how many nodes are present in different energy level pi-molecular orbitals, and HOMO, LUMO, electron configuration of molecule. So what are the pi-molecular orbitals? To explain all these points, I am taking three kind of examples. That is what ethylene, 1,3 butadiene, and benzene. Let me explain you as a first example ethylene molecule. In ethylene molecule, how pi-molecular orbitals are present and what is the energy levels of pi-molecular orbitals and what is the electronic configuration in ethylene molecule regarding to pi-molecular orbitals and which orbital is HOMO and which orbital is LUMO and what kind of nodes are present in ethylene pi-molecular orbitals. Right? Check. Ethylene molecule. How ethylene molecule is formed? CH2 double bond CH2 is ethylene molecule. Now, in this ethylene molecule, carbon atom is in sp2 hybridization. So, we want to explain these examples. We have to know what is sp2 hybridization. Hybridization means, let me take this example, carbon. Electronic configuration is 1s2, 2s2, 2p2. In excited state, 1s2, 2s2, 2s1, 2p3. S orbital and p orbitals. If this carbon atom wants to make bonds with hydrogen atoms, it undergoes hybridization as a central metal atom. Because here carbon is central metal atom, surrounding carbon atom there are hydrogens and other carbon atom. Understand? So means that this central metal atom undergoes hybridization. So hybridization, how hybridization is happen? If one s orbital hybridize mixed with one p orbital, one s orbital mixed with one p orbital, that is called sp hybridization. In this sp hybridization, two other orbitals are there which are not participating in the hybridization. You have to remember it. Then, if one s orbital intermix with two p orbitals, then that is called 1s and 2p orbitals. In this case, one unhybridized orbital will be there. If 1s orbital intermix with 3p orbitals, then that is called sp3 hybridization. In this sp3 hybridization, you cannot find any unhybridized orbitals. Right? Now we are taking example sp2. sp2 hybridization means one s orbital and two p orbitals are undergoes hybridization and the remaining one is in the state of unhybridized state. Structure, how the structure will be? Let's check. Carbon atom, when s orbital, two p orbitals are participating in hybridization, then they will produce three kind of sp2 hybridized orbitals. Means that before hybridization, orbital is like this. S orbital is spherical, p orbital is dumbbell, and another p orbital also dumbbell. But after hybridization, these three orbitals intermix together each other and they produce these kind of three orbitals. These three, just check it, these three orbitals are same energy, same shape, same size. Understand what I mean? So after hybridization, three orbitals will get the same energy, same shape and structure. But before, not like that. So now this is sp2 hybridized orbital, this is also sp2 hybridized, and this one also sp2 hybridized orbital. Now the one which is not participating in hybridization, that is perpendicular to this structure. For example, this structure is planar structure. Perpendicularly, this orbital will present unhybridized orbital. So this is the p orbital. If you check here, one electron, one electron, one electron, one electron. So means that here one electron is there, here also one electron is there, here also one electron is there. One more electron will be present in unhybridized p orbital also. Now another carbon atom also same. Another carbon atom, that is also same. That is also same. sp2. Here sp2 orbital, sp2 orbital, and the orbital which is not participating in hybridization will be perpendicular to the triangular planar structure. This is triangular planar. So to this triangular planar structure, this p orbital will be perpendicular. Right? Now, here there is a bond between carbon-carbon, sp2-sp2 bond, we can call it as, and here hydrogen will come. Here also hydrogen will come. Hydrogen s orbital, bonded with sp2 orbital of carbon. Okay, carbon sp2, hydrogen ssp2 bond is there. So such bonds 4 will be present here. Hydrogen. So 4 sp2 bonds are there. 4 numbers, 1, 2, 3, 4. One is sp2 bond is there between carbon atom. So another one bond is there, that is pi-MOT. We are going to focus on this pi bond only. Okay, fine. Now I am clearing this thing. Just check it. This is basic fundamentals. If you know these fundamentals, definitely you will easily learn what is happening in these 3 examples regarding pi molecular orbitals. Now, let me tell you ethylene example. Carbon, another carbon sp orbital, I mean unhybridized p orbital. If they participate in the bonding, they, according to molecular orbital theory, they produce 2 level of molecular orbitals. 2 atomic orbitals are participating, 2 molecular orbitals will be generated. The 2 molecular orbitals will be, one is bonding, which is having lower energy than atomic orbital, right? Other one is anti-bonding, which is higher energy when compared to atomic orbitals. Clear? Which is higher energy than atomic orbitals. Now, how the bond will be? If positive side, negative side approach each other laterally, then that is bonding molecular orbital. So this positive charge I am making it as shading side. For our convenience, shading side. Other side is unshading side, empty. So if shading side approach each other, positive side approach each other, they make a bond like this. Like this. If shaded side is approaches to unshaded, then the repulsion will be there in between two orbitals. So bond not will form. There is no possibility to form a bond. Understand? Because this is anti-bonding. This is bonding molecular orbital. Clear? Clear? This is basic. So now, when unhybridized 2p orbitals are participating in bonding, then they produce two number of pi molecular orbitals. Those pi molecular orbitals are pi bonding molecular orbital, pi anti-bonding molecular orbital. In this particular case, we can call these orbitals as psi1, psi2 or pi1, pi2. Here psi1 is bonding, psi2 is anti-bonding, so that we can give star mark. Clear? This is energy level. Now, let me explain you. This is pi molecular orbitals, bonding and anti-bonding. First point covered. Next point, symmetry. What kind of symmetry is present in these orbitals? Let's know that. Here, symmetry means whenever two materials are there or one material is there, if we can divide it into two parts, anything, this one or human being or any board, if we can divide it into two halves, same kind of resemblance is there between both of them after we divide. That is called symmetric in nature. That material is symmetric in nature. If we can cut it into two half parts, both are different. If they are different, then that is unsymmetric. Understand what I mean? Now I am taking this example. See, two orbitals are there. If we can cut in middle place, same mirror image is there. Same kind of structure is there after divide. So this orbital is called as symmetric. Symmetric. This psi2 orbital is unsymmetric. Okay. Symmetric, unsymmetric. Now you able to know that what are the pi molecular orbitals, how they form, and what is the symmetry between them. And next point, nodes. What is mean by node? Node also means that if we can able to divide with a point, which point will give you opposite sides, then that point is nodal point. Node, we can call it as node. Let me write you now. Like wave, see, both sides, upper sides are shaded. Both shaded. There is no point of node in psi1. So coming to psi2, one upside shaded, one downside shaded. So this point is node. So in this case, one node is present. Okay, here 0 nodes, here one node. Coming to electronic configuration, definitely here is one electron and here also is one electron. So two electrons are there in this system, two pi electrons are there. So that two pi electrons will be entered or occupied by the pi molecular orbital, because one orbital can able to hold two electrons. So psi1 will occupies with two electrons. Psi1, two electrons will be there. And less than psi2 is there, that is star antibonding. There is no electrons. Star. This is the electronic configuration of ethylene molecule. Right? This is, I'm telling you for basic information. So now let me explain you 1,3 butadiene in the same manner. Listen. Yes, 1,3 butadiene. In 1,3 butadiene, but means 4. 1, 2, 3, 4 carbon atoms. 4 carbon atoms are in sp2 hybridization because double bonds are there. 2 double bonds. Where the 2 double bonds are present? In the place of first carbon and third carbon. 1,3 butadiene. So first place, second place, third place, fourth place. First carbon having double bond, third carbon also having double bond, so that 1,3 butadiene it molecule can be called. So now remaining 2 bonds is with hydrogen, here single hydrogen, and here 2 more hydrogens, because carbon atom always bonded with 4 bonds. So surrounding 4 bonds are there for each and every carbon atom. Now fine. So these 2 pi bonds, before example we checked it one pi bond. Now we are checking with 2 pi bonds. Alternate. This molecule can be conjugated double bond molecule also. Conjugation means one double bond, one single bond, one double bond, one single bond. So now let me write you the molecular orbitals for 1,3 butadiene. 1,3 butadiene. 4 unhybridized, because this is also in sp2 hybridization, and this one also in sp2, this one also in sp2, this one also in sp2. When carbon is in under sp2 hybridization, carbon atom definitely have 4, here 4 carbon atoms are under sp2 hybridization. That's why I'm mentioning that 4 unhybridized p orbitals will be there. Right? That 4 are 1, 2, 3, 4. So 4 atomic orbitals are participating in this manner. So 4 kind of molecular orbitals will be generated. If 2 atomic orbitals participated there, then 2 molecular orbitals will be generated. If 4 atomic orbitals are participating in this procedure, then 4 molecular orbitals will be generated. Those 4 are psi1, psi2, psi3, psi3 and psi4. So half of them are bonding molecular orbitals, half of them are anti-bonding molecular orbitals. These 2 are bonding, these 2 are anti-bonding. In this particular case, so how pi molecular orbitals are there, that point is covered. Now symmetry and nodes. Symmetry and nodes. Let me explain it clearly. Symmetry. There is a trick that you have to remember it. If you remember that trick, you can easily give the shadings where we have to give the shadings to lobes. You can understand. For any kind of molecule, whether it is a 2 system or 4 system or 6 number system or 8 number system, even also, you can easily draw the structure. So if you easily draw the structure, you have to remember that a logic, that first you remember nodes, always nodes. For psi1, 0 nodes will be there. For psi2, 1 node will be there. Psi3, 2 nodes will be there. Psi4, 3 nodes will be there. what is the meaning of node? As I said, node means if we want to cut a molecule in different places, if opposite sides can be appeared when we cut it with a point, then node can be generated there. Our node is present there. Understand? Now tell me, psi 1. Psi 1 always, all lobes can be shaded same side. In any molecule, psi 1 always. Previous example also, psi 1 same sides. So see, all are same sides. Now if you can cut with a point, middle point, with a plane, same reflection will be there. These two are same, these two are same. If same reflection is there, that can be called as mirror image is there. So this psi 1 can be called as symmetric. Symmetric in nature. And one more point is that zero nodes are present. See, if you can cut with this point, you cannot able to differentiate both of them. With this point also you cannot differentiate. With this point also you cannot differentiate. So this can be, this is psi 1 orbital having zero nodes. Clear? Clear? And next, coming to psi 2. In psi 2, based on 1 node, I am using my intelligence that I am taking center point for node purpose. One node is enough. So center point I am taking first. With this center point, I am shading. See, both are shaded, and here these two I am giving shading. Positive, 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 positive. Means here a bond can able to form. Here also a bond can be formed. Here bond, here bond. That's why these orbitals are bonding molecular orbitals. Two double bonds. So in this case, with this point, we can able to separate these two parts separately. These 2 points. So now this molecule is one node. I mean, this psi 2 orbital is one node formed molecular orbital. And coming to symmetric point, here unsymmetry is there, because with this point completely this is opposite to this, this is opposite to this. So symmetry is present. Symmetric, this is symmetric. Symmetric always we have to select with center point, not here, not here. At center point, by based on the center point only we can separate. So with that we can able to tell whether the molecule is symmetric or unsymmetric. But coming to psi 2, it is unsymmetric in nature. Unsymmetric in nature. And next, psi 3. Coming to psi 3. Psi 3 logic is 2 nodes should be there. 2 nodes where I can keep 2 nodes. I'm always trying to give shaded to first lobe upside. I'm following this rule because this can give me very simple way to solve. So here upside shaded, and I want to make 2 nodes, right? 2 nodes. If I can take one node here, this seems to be unsymmetric. I mean, not proper. So if I can take one point here, I can take 1 point here. This seems to be good. When compared to, I can take these 2. Understand what I mean? That's why I am making a node here, and I am going to making a node here. If I want to make a node here, if shaded here, opposite shade should be there. Next, if it is shaded here, because there is no node should be there, and here this can be shaded. So in between there is a node, in between 2 of them there is a node. So psi 3 will be like this: shaded, 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 shaded. So means that in this case there is a possibility to give only one pi bond. But in these two cases, you can able to make two pi bonds. So these are bondings. But in this case, only one pi bond. So that is anti-bonding. Not able to give bonding. So and psi 3. So coming to nodes, there are two nodes at this particular point and at this particular point. This is node point. This is also node point. So one up, one down, two downs, and one up. This is node. This is node. Coming to this case, all are upside. Coming to this case, node point, two up, two down, one node. Understand what I mean? Fine. So coming to psi 4, coming to symmetric point, if we can cut it with this particular point here, we can cut it with this particular point here. See, these two are same with these two. Mirror image is there. Mirror image is there. So this psi 3 is symmetric in nature. Symmetric. Then coming to psi 4. Psi 4 I am taking three nodes. There is a critical and logic point. So three nodes means here one node, here one node, here one node, three nodes. So means that all are opposite. All are opposite. Very simple. You have to practice this 2-3 times, because once you started practice, it is very easy. Otherwise, little confusion will be there. So one up shaded, down shaded, up shaded, down shaded. Now nothing is possible to make a bond. In between both of them, there is no chance to form a bond. Here also there is no chance to form a bond. There is no chance to form a bond. So completely anti-bonding in nature. Psi 4. Anti-bonding. So coming to nodes 1, 2, 3. Node. 3 nodes, right? One up, one down, one up, one down. One node, one node, one node. 3 nodes. Clear? And then another point is that symmetric. What is the symmetric? Symmetric, always we have to select middle point, center point. So here I am taking a point. So if I can check here, this is opposite to this, this one also opposite to this. So means that this is unsymmetric. Unsymmetric. Next point, what I have to be covered? HOMO, LUMO. HOMO. Before going to that, let me tell you electronic configuration. Electronic configuration of this molecule. 4 unhybridized orbitals are there. 4 unhybridized p orbitals are there. So this is double bond. This is double bond. Pi bond. In this 4 unpaired electrons are there in carbon atom. So 4 electrons will be there. So that 4 electrons. So 4 electrons are participating in this. So psi 1 will occupies with 2 electrons because lower energy. Then psi 2, next 2 electrons will be occupied in psi 2 molecule. Next psi 3. Psi 3 will not get any more electrons because there are no electrons. So 0. Then psi 4 also anti-bonding. This is also 0. Fine? 0. Now, which orbital is HOMO, which orbital is LUMO? Let me explain. Listen carefully. Psi 1 lower energy, highly lower energy. Psi 2 next energy level. Psi 3 next energy level. Psi 4 highest energy level. Fine. Now coming to in the point of electrons. Psi 1 is having electrons, means occupied. This is occupied. Lower energy but occupied with electrons. Psi 1 is lower energy compared to other 3 orbitals and it is having electrons. So occupied lower energy, this one. psi 1. Coming to psi 2. In psi 2 also electrons are there. So psi 2 will be compared to psi 1 higher energy occupied with electrons. Coming to psi 3, there are no electrons. Coming to psi 4, there are no electrons. So in the point of electrons, psi 2 is the highest energy which is having electrons when compared to psi 1. In total system, psi 2 will be the highest energy with electrons. Clear? So that I am calling this molecule, this orbital as highest occupied molecular orbital. Highest occupied orbital. HOMO. Highest occupied molecular orbital. Psi 1 case, this is lowest occupied molecular orbitals. LOMO. Lowest occupied molecular orbital. Occupied, I am talking in the case of occupied with electrons. That's why I am mentioning this. This is the lower energy with electrons. This is the highest energy with electrons. After this, no electrons. That's why this is highest energy with electrons. Coming to psi 3, no electrons are there. Psi 4, no electrons are there. Means that unoccupied. These two are unoccupied. In this unoccupied case, this is the lower energy with unoccupied. So, lowest energy unoccupied molecular orbital. Lowest unoccupied molecular orbital. This one is highest unoccupied molecular orbital. So we don't bother about these two. We have to focus on these two only. HOMO, LEMO. Now you understand what is HOMO, LEMO? Highest occupied molecular orbital, lowest unoccupied molecular orbital. That's all. So this is highly enough to write 1,3 butadiene pi molecular orbital theory. If you can mention all these points, definitely you will get out of marks. If question is 10 marks, 10 marks you will get. If question is 6 marks, 6 marks you will get. If question is 8 marks, 8 marks you will definitely get.